Hello, in this video I'm going to be showing you what's left of the area of a right angle triangle once a sector with the radius r has been removed from it. To accomplish this task, I'm going to use the right angle triangle. R squared plus r tan theta squared is equal to r sec theta squared. There will also be two areas in this right angle triangle. The area of the sector with a radius r, called A1, and the area outside the sector, A2. What we are looking for specifically is the area A2. Now over here we have a radius of a circle, and over here we have the angle theta. Tan theta is opposite over adjacent, which is opposite over r. This means that the opposite side is going to be r tan theta. Now sec theta is hypotenuse over adjacent, and because the adjacent is r, then this is going to be hypotenuse over r. Therefore, the hypotenuse is r sec theta. If we remove r from the length over here, r sec theta, what we get is r sec theta minus r. And this is r times sec theta minus 1. So this length over here is r times sec theta minus 1. Now the area of this right angle triangle is A1 plus A2. And this is going to be r times r tan theta divided by 2. So the area is half r squared times tan theta. With all these important details, 1 to 4, it's going to be very easy to find the area A2. Our next step is to derive the area of the sector A1, and once we have that, we can remove it from the area of the right angle triangle to get the result A2. Now the area of a circle is pi r squared. The area of a sector is proportional to the angle theta. So the greater the angle theta is, the greater the area of the sector is going to be. This means that the area of the sector is going to be equal to the constant of proportionality times theta. Now when theta is pi over 2, or 90 degrees, the area of the sector is going to be a quarter times pi r squared. This means that a quarter times pi r squared is going to be equal to k, which is the constant of proportionality, times pi over 2. If we multiply both sides of this equation by 2 over pi, what we get is the constant of proportionality is half r squared. Since the area of the sector is k times theta, and k is half r squared, then the area of a sector must be half r squared times theta. So we know that the area of the sector A1 is half r squared times theta. We also have this equation over here. If we plug A1 into this equation, what we can do is isolate A2 to get this area up here. So if we isolate A2, we get half r squared times tan theta minus A1. A1 is the area of the sector, okay? So this means that A2 is half r squared times tan theta minus half r squared times theta. If we simplify this, what we get for A2 is half r squared times tan theta minus theta. So this is how to find the area A2, that is, removing the area of a sector from a right angle triangle. As you can see here, the right angle triangle r squared plus r tan theta squared is equal to r sec theta squared has a very useful application. I've left the link to these workings below this video. For more mathematics proofs videos, make sure you are subscribed to my channel. As always, for extra mathematics proofs, visit mathematics.proofs on Instagram. Thanks for watching this video, and I'll see you next time.